Pakistan, parts of the Middle East, like Saudi Arabia and others, we are in the red zone. The red zone is when, so let me explain the concept of wet bulb temperature. Humans all have like a body temperature about 98 F, I think it's about 36 degrees C. At, well, I think it's about, at about 35 degrees C, wet bulb. So wet bulb is measured by actually taking a standard thermometer and putting a cotton cloth at the bulb end. And as air goes through it, the evaporation of air, of water, cools down the bulb. And the lowest temperature you can go is called the wet bulb temperature, which means this is the minimum temperature you can achieve by evaporative cooling of water from the as compared to the normal temperatures. Now, at 35 degrees C wet bulb temperature, a human being sitting naked under a fan will not survive, because they will actually absorb heat from the environment and they cannot cool themselves down, and they will overheat, and therefore they will die of heat stroke and heat exhaustion. This has happened in Telangana and Andhra Pradesh. In 2015, there was a heat wave which killed many people. But what I'm trying to say here is that this is a massive threat that all of us, whether we are engineers or whether we are lay people living in such high wet bulb. Hello, can you hear us? Hello, Anita.
Yes, sir. Somebody,
yes,
we can hear you, sir. Somebody went on unmute. Now I have muted him.
Okay, so so India, especially peninsular India, as you can see here, is at great risk for such heat waves from coming in again and again. The only way to survive such heat waves is by sitting inside an AC. Okay, you can't go and do any work. If you go outside and you walk around, you're likely to die. If you are a auto driver without AC and you go out into this heat stroke, you think, I can survive, maybe with enough water, you will die. And what is going to happen is such instances of heat waves are going to go beyond the wet bulb temperature of 35 in peninsular India more often now as we start increasing the amount of greenhouse gases in the atmosphere. Okay, so this is a threat that is going to happen, is happening, and we have to now start designing our cities, our systems, not just our homes. We have to start designing entire communities, entire cities, entire countrysides, entire districts perhaps, to start ameliorating such situations. And this is what I would now call as environment management, and not just the municipal concept of picking up solid waste and all that. Now we have to start thinking about this as a system of systems, an integrated environmental management system. Okay, so obviously what happens when such heat strokes and everything happens, there may be no other option. Suppose things goes completely south, we have to find a place which is green in this map to survive, because once the wet bulb temperatures reaches say 33 or something like that, even the plants that you have, your agriculture collapses, your people can't live, you will have mass migrations, and India is actually at the highest risk here. And we have to take drastic action to solve this issue now. Okay, so what is integrated environment management? Now, we have talked about the atmosphere, the hydrosphere, the lithosphere, and of course, now I am putting in human intervention or the human environment, because not only do we have long-term or short-term threats due to climate, but also we have an economy that we have to run. Now, the good thing is, sustainability and circular economy and climate change are now things everybody is talking about. And there is a lot of business that can be done integrating all these things, which I'll talk about as we go ahead. Now, the atmosphere, obviously, we have to manage the wet and dry bulb temperature. We have to look at air quality. We are looking at CO2. We are looking at oxygen levels. We have to look at SOx and NOx levels, VOCs, ammonia, H2S, which causes bad smell and things like that, dust levels, and also noise. So that is the atmosphere. How do you manage that? I'll talk about models. I'll talk about ideas as we go along. The hydrosphere. So of course, the hydrosphere is massive. It's 2/3 of the Earth. But what we find is that the human engineering has brought in a lot of fresh water into our cities. The fresh water goes through our house. It converts into wastewater. And after the wastewater is there, the carbonaceous waste that we as humans have generated in our highly dense colonies then goes into an aquatic environment, which is not suited to handle it. As I pointed out in the carbon cycle slide, it's very difficult. You need to give a lot of energy to give oxygen inside that water. Okay, but apart from that, we have to manage our lakes, our rivers, our glaciers. All of these are environmental assets that cities now have to very, very clearly think about. Because if you don't think about where you're going to get drinking water, say Hyderabad, city of Hyderabad, uh, because of the temperature fluctuations, you will have the situation which happened in South Africa, Cape Town, which ran out of water and people had to survive on, I think, 2 liters of water per person per day, which means nobody took bath for months. And these are situations that have to be designed for today. The only reason why India, even though it is, you can see it's mostly in the red zone, we have survived is because of the copious monsoon season that comes and replenishes water on the Indian subcontinent. But unfortunately, we have not done a very good job of shepherding these water assets. You need a huge quantity of fresh water to be able to survive these fluctuations in temperature that you're going to get. So people are talking about rainwater harvesting and people not following it. It is, I mean, I don't want to be use very strong words, but it is true. If you do not have, and you citizens of India probably don't realize, but we have not had a system where the government has understood these threats as well as some of the other governments have done. For example, China has invested a huge amount of resources in shepherding its water, in trying to store water under its control. What it does, its control on Tibet, its control on the Himalayan glaciers, the military pressures it is applying there actually has a climate change component to it. A lot of people don't realize why they're doing it, because the origins of all the major rivers of the Indian subcontinent and of Asia is controlled via Tibet. And that's a tap that all of us know is important. Of course, a lot of the fresh water that comes into India is coming by the northwest monsoons, which of course we have not done a very good job of creating these water storage structures. We have started doing something now piecemeal, but really speaking, you need to have like a community effort to have like these massive reservoirs that are able to capture the high peak rainfalls that come and then put it under the ground so that we can use it for cooling activities later. Without that, we will actually have a lot of problems as we go along. Okay, so of course, the lithosphere for biological solids composting, resource recovery, we are doing a lot of industrial activities, and we must be able to design our industrial activities for complete recycle. So nothing should be once through. So whenever we manufacture any item, you know, whether it is this mask or whether it is these earphones or whether it is these construction materials that we are using to make our houses, we have to now start thinking about how we can reuse these building blocks to make other things. Very quickly be able to convert one facility into another by reusing these building blocks, because that's what nature does. Nature actually, when suppose as humans and as organisms, when we cease to exist, we collapse into the ground in a rainforest where other organisms tear us apart and then make their own bodies out of it. And that's the design of nature. And that same should be the design of human activity also. We have to design our cities, almost every activity that we do now has to be designed from an aspect of whether what we build can be easily dismantled and then converted into something else at some other location very fast, very quickly, very efficiently. So that's something which I call as recyclable design, which is something which a lot of people are doing. They're talking about it, but now it has to be seriously implemented. And how we design the human environment itself in terms of productivity enhancement, in terms of collaborative environment, in terms of having space for recreation and public health and mental health, all of that has to be integrated so that we as humans can guide all of these other integrated environment management. Okay. Um, I'm now showing you this picture of the Amazon. Okay. You see these small popcorn-like clouds in this satellite image. This is actually the Amazon sucking up groundwater from the Amazon forest, sucking up water from the root zone of the trees, converting it into water vapor in a process called transpiration. And this then rises up in the atmosphere and forms these clouds. So in the dry season, the Amazon rainforest itself creates its own thunderstorms. So you see some of these thicker clouds, they're actually thunderstorms. And what happens is that this actually triggers the release of heat in the atmosphere and changes the trade winds, which then comes and dumps a huge amount of rainfall again in the Amazonian basin. Now, people don't realize, but India, maybe about 3,000–4,000 years ago, was also a dense forest, very similar to the Amazon. Okay, so many of us in our mythological epics may have heard of, Aranya. Lord Rama went from Ayodhya and Kishkinda down south, and he crossed these massive forests. And this was the case even until recently. That it is only now, maybe in the last 1,000–1,500 years, that many of these vast forests have been now converted into farmland. And what has happened is that farmland is not there all the time, and it doesn't transpire as much water vapor as a mature, fully grown rainforest does. And this has changed the climate around and above India from a tropical rainforest ecosystem, which used to have daily rain, to something that we have to now depend upon the rain that comes in only once 3 months in a year and rains on us, and then most of that rainwater goes away into the sea within a few days. We have not created any water retaining structures. We have not created any contour bunding. We've not had a national enforceable water conservation system at all, partly because we have too many laws that conflict, and it seems to be a problem in order to be able to do some of these activities. Now, how can we do things at small scale that can help us create what I call these transpiration engines across India? There are lots of interesting ideas that have been tried. We know that in India, sewage is being used by many farmers for agriculture, so that is well known. But a lot of the sewage that is being generated by many of our cities is being discarded. Of course, a lot of STPs are being made, and that's a good idea. But one of the things that many cities should consider is called sewage irrigated forests, okay, which then converts the wastewater that is generated by our communities into these dense, productive, economically productive forests that give you raw materials for building, like bamboo and cane and shisham and eucalyptus and many other things. So biologically fixing the wastewater, photosynthetically taking the CO2 from the atmosphere and fixing it as living carbon in these forests, which then become our cities. So rather than mining the earth and then converting and making cement and steel buildings, we can actually start looking at agroforestry using wastewaters of our cities and then using a lot more of these renewable resources like wood to create our living spaces. Okay. So with this, I want to now introduce, Vision Healthcare has been working on this for a very long time. Now I want to introduce our concept called the Peacock EcoCity, which combines all these concepts into one single integrated whole that can be designed as an integrated or a decentralized city. Okay, so let me just go through this walkthrough. So what we have is a built space. Of course, here this is a standard framed RCC construction, which is able to sustain a mixed-use population of about 10,000 people with retail space, office space, living space, recreation space, all of that with a very fundamental, with a design where we leave the ground to become what is called as a natural sponge. So all the recreation areas are moved to the top of the terrace, which is also a green terrace. The residential frontage looks on the inside, which is the environmental forest, which is, you may call it the sewage irrigated forest or a treated water irrigated forest, which is used for heat management. This actually uses the wastewater generated by the community to create this lush, dense rainforest inside your complex, which is your mini Dandakaranya, if you want to call it that. And this is a place where you can interact, not just a space where humans use, but it's a space which animals, wild animals can use. So rainwater that is impinging on this is then captured completely, and then it is with permeable pavements, it is being pushed into the underground aquifers of that area, so that we are designing a city or a community which is net zero, or it doesn't need to bring in water from outside. It is able to harvest its own wastewater and rainwater, and enough for its own water needs. The duck farms can be put in, fish farms can be put in. This is a nature-based wastewater recycling plant, which we have done about 140 MLD across India already. We have a solid composting system. It is also having a facility to break down furniture and all the other utilities that you use in daily life and make something else out of it or use it for some other projects. So this is the conception of how to use wastes and convert it into a value-added system. And as we integrate all these things, we call it the Peacock EcoCity. So which actually does many things, like the air management, the heat management is done by the forest in the middle. Second thing is that because of the profusion of leaves, the area on which dust can settle is also very high. Because of the availability of treated wastewater, you can actually use it to bring down dust levels in various places. The treated wastewater can also be used for anthropogenic activities like cooling towers, so that the built space can be cooled more effectively. And there are many ideas like that. But the reason, what is happening today is that city planning or urban management today, the municipal parks are not being designed as these green zones or these Miyawaki forestry or permaculture forests, which will act as the heat management lungs of the city. We are living in a dense city, and next time we are going to have this heat wave that comes through, it is our glass-clad buildings, our completely paved over streets that do not allow us to put water into our underground aquifers, which are going to cause us a huge problem, and we need to start correcting it by design today. So making on to the next, so what would we actually travel in such a city? You know, there are so many interesting ideas that you can implement when you have these, urban rainforest parks in the middle of your colonies itself. You could actually have humans, rather than traveling from one place to the other using vehicles, actually walk through the canopy of these rainforests as we develop them from one place to the other. With commutes, rather, I mean, the initial, the concept is quite unique and interesting and still necessary. But all of the short trips that we make for our daily essentials can be covered by using paths like this, by maybe cycles and walking and, being one with nature. And that's the kind of urban design that has to be integrated now. So how would you design such cities like this? So once we have these Peacock EcoCity nodes, we can actually cluster and network all the rainwater harvesting ponds with each other, so that if there is a lot of rain on one side, the water from that side actually can flow and fill up all the rainwater harvesting ponds of all the different locations. Of course, we have not done any kind of city planning which integrates that, yes, you must have a rainwater harvesting pit, not just a pit, but a pond. Because what happens is that you have a huge amount of rainwater coming in, and your pond will actually hold that for a week or two, or whatever design that we do, so that it has ample time for that water to go down. Okay, not immediately. You cannot design a harvesting pit that will take the peak rainfall available in your location and put it into the groundwater. That will be too expensive. You'll have to have too many bores. But once you have a rainwater harvesting pond, the pond level rises. So you have enough space. It's like, oh, we have some space there. And then that is then connected to a whole bunch of rainwater harvesting pits, then puts everything into the aquifer. If the aquifers are full, then the rainwater harvest pond can overflow to the downstream ponds and things like that. So once you have an integrated city where everybody's waste is actually not being thrown away into the atmosphere or into your ponds and rivers and lakes, it is being used for heat management, you will find a 10x improvement in terms of quality of life, in terms of energy that you will consume. Heating is the largest user of energy in a city today. Okay, it is approximately every kilowatt hour of energy produced. Well, we are supplying about 135 liters of water per person per day, out of which India, I think the Indian power consumption per capita requires about 4 to 5 liters of water per kilowatt hour. So we consume around 3 kilowatt hour per person per day of electrical power on average, which includes industrial electrical power and everything also. So that is about 15 liters of water per person per day is being used just for the production of electrical power. And that can be reduced if you use evaporative cooling using these green forest zones for heat management. Okay, so there are other concepts. We have many requirements for creating such water holding ponds and rivers and maybe contour dams in your locations. You can convert, or you can make very interesting features of integrating nature with ponds, water holding features, so that you can get this integrated use. So this is a concept that has been developed by Vision Healthcare that is using what is called as these Aranya Dwip, which in Sanskrit means a forest island. What we do is that we take an existing lake, or we want to create an existing water holding feature because we need to conserve water. And that is by taking flat land and digging that flat land. Whatever earth that comes out, we then make these islands. We convert those islands with these native forest species. The monsoon rain comes and inundates this region and makes it into this monsoon pond. And the trees and forests grow in it, which is not a space for humans. It is a space for our fellow beings on earth. It is the wildlife. It is the storks, the squirrels, the foxes, the alligators. All of these also have a right to live in our environment. And these forest islands are this sanctuary for them. The water itself will be used via the aquifer for human use. the pollution that we create can be treated within these forest islands using many technologies, nature-based technologies, which I'll talk about. So first one is this SBT technology. Anita madam, how am I doing for time? Hello?
Yes, sir. We need to close the session, sir. 5 minutes more you can take,
5 minutes
sir.
more?
We
I'll
can
finish
close the
right
session.
now. Okay.
Thank you, sir.
So this is the CAMUS-SBT type wastewater treatment plant, which is essentially using soil bacteria and soil ecology to treat wastewater. So these are some plants that we have implemented. This is a plant that is about, I mean, right now, these pictures, the trees have become much bigger. And I'll talk about this in the next slide. Our oldest installation is from 2005. So you can see here that people are actually living in front of an STP, not realizing that there is an STP here. Okay, so this is a concept of the first Peacock EcoCity. If you want to sort of, I mean, it is not fully an EcoCity because we have not implemented the heat island or the heat zone cooling system. The forest zone we have not implemented in this, but the treated wastewater is being used for dust abatement purposes across this entire society. The roads are washed with the treated water, cars are washed with the treated water, and flushing is done by treated water. So they are using only 60 liters per person per day of water in this society as compared to 135 a standard municipal authority has to provide. South Bombay uses about 200. We've done a few airports. We can do individual houses. This is the BMC plant where the treated wastewater is used for the Bombay Presidency golf course and the Wellington golf course and the Mahalakshmi race course in Worli area. This is Devprayag, which is the confluence of Bhagirathi Alaknanda. This is the wastewater which is coming into this plant here, and this is the treated sewage water which is used for all non-contact reuse purposes. It can be used for construction, RMC plants. You can use it for dust abatement. For example, India is one of the air quality in India is quite poor. The reason it is poor is because we have not, 1 minute. Yeah, we have not managed our wastewater well. And once you treat your wastewater, you can use that wastewater, treated wastewater, to reduce your dust levels. You can wash your roads. A lot of the dust that you're seeing in Indian cities is actually tire dust. It is the dust generated by the friction of rubber tires on our asphalts and our macadam roads. If you do not treat your wastewater, that wastewater becomes a curse which goes and pollutes your drinking water sources, your ponds, your rivers, your aquifers, and is not utilizable anywhere else. Okay, so this is something which we have been talking about for the last 10 years, and a lot of traction is now there with the ability of nature-based systems to give you high quality treated water for all such environmental purposes, which is required. And this is something which we have now integrated into our concept called the Peacock EcoCity. So of course, there are many other systems. Excuse me. Sorry. So these are some small interventions which, in terms of environmental asset, you are putting all these non-biodegradable plastics into our water streams, the rivers and oceans. There are certain interventions that you can now start doing so that you don't, at least this is the minimum that we can do with minimum effort. This is not to the scale of global climate change kind of things that we have talked about before, but let's start small. These are some interventions that all cities can now implement so that the plastic waste that is now causing destruction of fish habitats and marine habitats, we can now sequester at the point of generation itself. Many of our cities, we are not, during the rainy season, all the plastic detritus that is people have thrown here and there, they get washed into our drains, and we can actually use the power of nature itself to collect that at the beginning during the rainy season using these net bags. There are other concepts which have already been implemented in India. This is somewhere in Chennai, where there is a floating trash barrier that is on the Coombe River that captures all the floating waste. What you're seeing here is approximately 30% is plastic waste like thermocol and floating bottles and bottle caps and many plastic items. The rest of it is things like food waste and plant waste and things like that. But such interventions you can use to make sure that it doesn't cause an aesthetic depreciation of your water bodies. That's a very important thing that can be immediately implemented at low cost. So this is a floating trash barrier on the Coombe River, I believe, again, or maybe in Pondicherry, I'm not very sure. This is being done by a company in Bangalore called Alpha Mers that works with us. So this is something which collects all the trash. It is designed in a way that all the trash is brought to the side of the river, so that you can use a JCB to take it to a recycling center, where you can either convert it into value-added products, or you can use it to create artificial fuels or building materials. There is lots of interventions that have been tried out where you can take plastic waste and then melt the plastic waste into making plastic enriched roads, which are having higher performance characteristics. You can monitor our assets. So many of the things that we do before we can do any kind of understanding, we must measure the quality of our environmental assets. So we have a system which does floating online quality monitoring of all our rivers. So if you want to monitor the quality of Hussain Sagar Lake, you put in a floating device which measures the COD, POD, and TSS and things like that. Interestingly, one of such devices had been placed in Najafgarh drain in Delhi. And you can see that this was put there, and it collected data before the COVID lockdown started, which is an interesting thing that we did with our equalizer system, 4M system. So you can see on 22nd March, the Najafgarh drain, before the lockdown started, had a COD of about 180 or so. And March 23rd, I believe the lockdown started and all industrial activity stopped. So the blue is the COD. And as it stopped, you can see that the COD levels kept going down. So what it really means is that here is an example of anthropogenic activities. When stopped, the pollution levels in the water reduced. And we are using such online monitoring, persistent online monitoring solutions as a method to monitor the quality of our water assets. Who is doing pollution when is something that can be monitored by putting such devices all along the Ganga, if need be, all along the Kaveri in Andhra Pradesh and Telangana. On Hussain Sagar Lake, you can understand you can do this even in your aquifers, which is at the bottom. You can monitor the quality of the aquifer on an online basis. And this is something which is very interesting and allows us to understand and correct problems of pollution in various water bodies. So coming back to how we as a society can handle all these things, the ideas and the interventions that we had talked about have many options in turning into businesses and jobs. So I'm going to list out some ideas that people can do in order to take what is considered waste and then create value-added products and services. And governments have a very large role in the implementation of such things. For example, I know I can do this, but unless the government agrees to procure that for its own, tendering systems, it doesn't have a ready market. And once the government becomes a large market, it gives you that economy of scale, and the private sector very quickly follows in utilization, because now they know that the government is a anchor buyer. It will always buy the base loads, and the private sector can then now come in and then procure things knowing that the supply is there. So when I say things like recycled plastics or recycled, road, plastic enriched roads, or, many things that are this thing. So there is one is asset utilization. Many of the environmental assets that have been created are not being utilized efficiently. Things like you have a lake, developing it, not just developing a lake, but also using that lake for fisheries or for duck farming and things like that, has a value added component to it, has a tourism component to it. The governments and the people and the communities have to come together in order to create some new methods of entrepreneurship, which is enviropreneurship, which we should now look at. So we must have a superior energy harvesting. We must look at shared economy. Like, I'm not utilizing my car all the time, so now it is much more convenient for all of us to go for an Uber. There might be other models where we have, back in the day, villages used to share a community kitchen. So you have concepts like a community kitchen, because we are not using our kitchens all the time. Perhaps maybe it is a better idea to have a community kitchen where we can go and cook together and then learn from each other and things like that. So looking at total life cycle cost analysis, there are multiple business models. We as a business in this could be catering to consumers, or we could be catering to other businesses, that is a B2B model, or we could be catering to governments in various ways. And then we also could be catering to communities like housing societies and cooperatives and things like that. And there are many players. So there are techno entrepreneurs who come from educational institutions, research labs, and innovators who are designing and implementing technology. There are companies that will take these technologies and the IP that is being generated and then take it to market, and then delivering scale from a lab scale to the economical scale. Governments, policymakers, ecosystem creators, they have to understand the very critical role. The government cannot sit back and say, it cannot just be, it has to be backed with money. And that's what I think China has done very successfully. It actually buys in bulk from its own entrepreneurs. So the entrepreneurs in China know that the government of China will buy a huge amount of materials from the Chinese entrepreneurs and Chinese private companies. And that allows them an economy of scale. For example, a Chinese company is able to invest. Today, I think, has 95% of the world's solar market production is in China, because the Chinese government is now going to be a critical buyer of these modules. And so India, of course, only imports all of it. But the Indian government has not done enough, I believe, to support its own entrepreneurs in terms of being the anchor client. The US government does it, the Chinese government does it, most other governments do it, but the Indian government does not allow innovation support as much as it requires it to be done. Of course, there are citizen NGOs and watchdogs and many other things, but they all have to come together to understand and solve the challenges that we all face. And yeah, with that, I am mostly coming to the end. If there are any questions, I can answer them now, but I am done now. Anita madam, hello.
Yeah. Thank you, sir. Thank you so much. In chat box,
Okay.
your presentation has been appreciated by all the participants. Very informative and useful information. And with this, I will share your email ID to the participants also. So in case of any queries and any other interaction, if they want to have, they can have with you, sir.
Sure, no issue. Thank you so much.
Very good. One group photograph. Very good.
Yeah, group photograph we can take. Kindly all of you put on the camera on so that we can have one group photograph. Yes, sir. So now, with this, I would like to extend my vote of thanks to Dinesh Kumar sir, Chairman SN Rao sir, and Director sir, for sharing the details and on the outcome of the program, and all of you who all are present at this occasion. And thanks to our faculty, Dr. Chandrasekhar, for his valuable presentation and the talk on wastewater treatment plant. And I would also like to extend my vote of thanks to all the participants, ladies and gentlemen, and all of the faculty members who all have attended this training program. I wish to express my gratitude to the participants for their participation, involvement, and willingness to take the completion of the task. And with this, Mr. Sai Kishore, have you taken this group photograph?
Yeah, they have to switch on the videos, ma'am.
Kindly, all of you, please switch on the video cam who all are not on the webcam.
For a minute, can you switch on your videos?
Yeah, we'll take 1 minute.
It's 1, 2, 3.
Yeah.
Thank you.
Thank you so much. Now we'll stand up for the national anthem, and then we can conclude the session. Thank you.
Here we need to stand. Okay.
शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत माता जय हे जय जय
Excellent. Congratulations.
To one and all. So we can conclude the session here. And as in chat box also, you can see every day we are having webinar series for this PGDM course. And feel free to go our Telangana IIA State Center. Tomorrow also career counseling is there. Counselors are there. They will guide you also. Thank you. Thank you so much.
Thank you always.
Thank you, sir. Thank you, Alto.
Request all the participants to spread across the message regarding the infrastructure management course as well as the general management course, which has been organized by Engineering Staff Club India for 2 years. So just spread the message across. Thank you very much.
Thank you, Dr. Chandrasekhar, sir.
Thanks
a lot.
Sure. I hope it was.
Thank you.
Ma'am, you can end the meeting.
Anita madam, hello.
Yes, sir. Tell me, sir.
Is there a video recording of this?
I'll check, sir. If it is there, I'll get back to you, sir.
Okay.
I'll ask my IT team and then I'll share with you.
It is recording, so I just want to, yeah.
Yeah, recording is there. Recording it is happening, so I'll share the link.
Okay, thank you so much. If you can put
Thank
it on
you,
YouTube, it will be nice. Okay.
Okay. Sure, sir. Sure.
Please do email to your lecture to my yes, it is very informative lecture as an environmental.
I will send it to you, sir. If you have, I don't see your email address.
Achha. I am putting the email address to chat box.
What I'll do is I'll put it on my this talk. I will keep it on my. I'll send you a link of that.